All right, join me here on page 279 in your book, and we're going to do the warm-up here together, and it asks us to remember some basic things about fractions. So when you have a fraction, like the fraction 5 over 2, that means that you're multiplying, right? You're multiplying by 5, and then you are dividing by 2, all right? I wish I had my Apple Pencil. I left that behind. So you're multiplying by 5, dividing by 2. So you can do those either way. You can divide by 2 and then multiply by 5, or you can multiply by 5 and then divide by 2. And you'll get the same answer either way. So that leads us to this right here, this one. So dividing by 2 into the 4 would be 2. So if we divide the 2, let me make this bigger. So if we divide the 2 into the 4, we would get 2. And then you would have 2 times the 5, which would be an answer of 10. You can also just multiply straight across. You could do 5. Let me make myself some more room here. Let me get my eraser going here. You could also just multiply 5 over 2 times 4, which is like 4 over 1. And then you get 20 over 2. And you're like, well, why don't I just use a calculator? It's because we have to understand in this section what these fractional exponents are telling us, right? There's the bottom of the fraction tells us something, and the top of the fraction tells us something. So that's the name of this section, is let's use roots to write exponents that are fractions. So positive rational exponents is the lesson here. So 20 over 2, of course, is the same thing back to 10. All right, let me clear this page. So I'll hold this down, hit clear page. All right, so try these, and then we'll go through the answers together. Let me make it a little smaller now, and go. All right, 5, hopefully you paused it so you tried them. 5 times 4 is 20, and then half of that is 10. We already decided that, excuse me, that this was 10. And then the 3 over 2 is like multiplying 3 and dividing by 2. And then the 2 over 3 is like multiplying by 2 and dividing by 3. So those are opposites of each other. So they actually cancel each other out. And the answer is just 7. So that's why they're saying do it mentally. Don't type it in the calculator, because you're trying to understand what these fractions are telling us. This one here, we have 3 on the bottom and 3 on the top. Well, those cancel each other out because they are opposite of each other. This is like 7 over 1, so 7 on the bottom, 7 on the top, cancel each other out. So you're just left with 5 on this one. So it's 10, 10, 7, and 5. And I'm going to get myself a real quick drink of water because I am starting to cough. All right. Thanks for being patient there. I'm afraid to pause the video because I'll have to start it over again. So, all right. This is getting at the fact that what fractions are, right? So basically what I just said on the first page. The 2/3, right? It's multiplying by 2 and then dividing by 3. So that's what the 2/3 means. So these are equivalent to each other. These are equal. Why are they equal to each other? Because when you have a power raised to a power, you multiply. So in this first one here, we have 1/3 times 2. And then the second one, we have 2 times 1/3. So this is the same thing as 5 to the 2/3 power. So those are equivalent to each other. So what do these radical exponents mean? Well, I'm going to sing a little song after I take a drink of water. All the students know the exponents E-I-E-I-O. So the top is the E and the bottom is the I. So every single time you see a fractional exponent, the top is the E. E stands for exponent. Exponent, right? And the bottom is the index. All right, so it's E over I. So the index goes with the radical and the exponent goes with the exponent. So here we go. We're going to write what these are. Number 2. So it's 5 to the 2/3. We're going to rewrite this with radicals. So we're going to write the radical symbol, which is, if there's nothing, it's a square root symbol. But in general, just this symbol is called the radical symbol. So the bottom number is the index. That's the 3. It goes right there. All right, so that's the index. It goes on the outside. And then on the 5 is squared. Then you can rewrite this as 3 radical symbol, and then 5 squared is 25. So that's how you can rewrite this. So there we wrote the 2/3 power is now the cube root of 25. All the students know the exponents E-I-E-I-O. 3. So this would be 5 to the 4/3 power. 5 to the 4/3 power. So we make the radical symbol. And the 3 is your index, so it goes right there. And then it's 5 to the 4th power. So this is 5 times 5 times 5 times 5. So if you have your yellow paper or your white paper of shame, you can know what 5 to the 4th power is without typing the calculator. So it's 25 would be 2 5s, times 5 would be 125, and then times another 5 would be 625. So it's the cube root of 625. So all the students know the exponents E-I-E-I-O. The top number is the exponent E-I-E-I-O. The bottom number is the index E-I-E-I-O. All right. So hopefully you can remember that, exponent over index. Next page. So you can also use the caret key to type these in. You can get decimal approximations. You can make a graph here. We don't need a graph for some of them. And then you can plot the points down here, and you're going to see an exponential curve. So if you graph these out, you're going to see like a curve go up like that. Something along those lines. I just smashed it on there real quick. But 2 to the 0 power, of course, is 1, right? 2 to the 1st power is 2, and then 2 to the 2nd power is 4, and then all these others are going to be in between 1 and 2 and 2 and 4. So you can type them into the calculator. You can do 2, and then you can use the caret key, like so, and then you can do parentheses, and then you can do 4 divided by 3. And that would do this answer right there. And you can get a decimal approximation. You can see how this grows. Complete the table as much as you can without using a calculator. So I did that, and now you start typing the calculator. You can make a graph and see how it works. All right. Down here, that is just talking about like when you have a power raised to a power, right? What do? You multiply the exponents. So we have 2 to the 3/3, which is just 2 to the 1st power, or just 2. And then the 1/3 power is just the cube root. We talked about that already. So that's just the cube root of 2, right? Let's see. Next page. Oops. So rewrite using radical notation. So we'll do this one again. All the students know the exponents E-I-E-I-O. All right, so what do? We make the radical symbol. And the 3 goes right there because that's your index. And then the 2 on the top is the squared. So it's 2 squared. So then you get the cube root of 2 squared. 2 times 2 is 4. And then that's it on that. Ready for more? Well, you could type those into the calculator, no big deal. And here's the summary page. All right. Didn't mean to do that. Let's see. Let's go back to the pen tool here. What's this summary page say? This is on page, what is this on? We're on the orange page, 283. On 283, it summarizes what we talked about here. We have the 1/4 power means the 4th root. We talked about that the other day. The 1/3 power means the 3rd root. We have the 4 We have the 5/4 power right here. So it could be written either way. It can be written either way like that. And then of course the EIEIO business. So you would write the let me see. Let me get rid of this. Let me do it again. So make the radical symbol first, and then the 4 on the bottom right here. I'm looking right here. So the 4 on the bottom is your index, and then it becomes 3 to the 5th. And of course, they gave it away. 3 to the 5th is 243. Then they give you an example of what it looks like with 5. It's the same chart that you filled out on the other page, but then they did it all for you here. All right, so here's the purple page. Oh, blank page, and purple page. And there are, this is a short, sweet, to the point 6 questions. All right, so we're evaluating number 1. So it's going to be an actual real number, right? So let's look at that one together. And if you get stuck, you can always type it in the calculator. But basically, right, we make the radical symbol, right? And then it's actually easier on this one here because 8 to the 5th power is a huge number. So it's actually easier to rearrange it this way, to put the cube root of 8, right? And then you can raise it to the 5th power. So that's the switch that we talked about in the very beginning. Because it's much easier, right, to take the cube root of 8 and then raise it to the 5th power. Instead of doing 8 to the 5th power and then taking the cube root, 8 to the 5th power escapes me, but the cube root of 8 can be done first. So that's what I said in the very beginning of fractions, right, in the warm-up. So the 5 on the top can be done first, or the 3 on the bottom can be done second with fractions, because you can divide by 3, multiply by 5. You can do either one of those, and it doesn't matter when you're working with fractions. So the same thing is true with these exponent things. So we have I always say with something like this, you want to take the cube root first, and then raise it to the 5th power second. And I would do the same thing with this one here. I would do the index first. So I do 64, and I would take the square root of it. I don't need a 2 because square root does mean 2. If you want to put a 2 there, you can. And then I would get an answer to that and then raise it to the 3rd power. All right. Number 4 is a old school review one. Then this is review. Number 5 is review, and so is number 6. So what's the 1/2 power mean? 1/2 power. What does that mean? That's what they're asking you here. It doesn't mean A for sure, right? What does that 1/2 power mean? It's from the lesson the other day. All right. Get this purple page done and turned in.